Hello everyone. Today our topic is era of development F5 network. So over the time period, how the F5 network has been developed, what are the old device to overcome the drawback of old device, what are the new device come to the market, that all we can cover under this video. So without wasting time, we just started with the era. This era started with 1990s. So in 1990s, the first product in the market is the DNS to overcome. So if we use only one server and deploy the URL on the same server, the redundancy, there is an issue of redundancy, it can't provide. So I'm just talking like to client to the server, right? It's a client to server architecture, definitely. So if we, here is the internet. So if we deploy any of the URL over the say one server, then if it is down, then it stop working. Also, scalability is not there, the bandwidth limitation is there, RAM utilization of the particular server is high, then it's also the if number of client increase drastically over the time period, then also one server can't handle this request. So in 1990s, to overcome this drawback, the team came with the DNS server. So DNS server, what DNS server do is again the client to server architecture. There is a DNS the DNS server we use here, right? So for any of the URL like xyz.com, right? xyz.com. So what we can do here is for the xyz.com, instead of keeping this xyz.com on server 1, we kept this on server 2, server 3, server 4, likewise. So let's consider server 2 and server 3. Same URL is deployed over these three server, and to load balance the traffic between that three server, we do use the DNS. So first request and its traffic should shift according to the round robin method. First request goes to the S1, second goes to S2, S3. Likewise, from again it's come to the S1, S2, S3. Likewise, the traffic is hitting to that server uh, round robin fashion. So again, it's having some drawback like if one of the server is down, we get the error. Instead of it shifting to the other server, we lost our connection for some time. Also, it's don't have the capability of it's only have a capability of round robin fashion. It don't have any. So if the server memory, one of the server memory is high, one of other server memory is low, then in that case we can't prioritize the server. That is also a drawback. To overcome this drawback, also the connection limit, the most important is connection limit. So basically connection limit is limit, so if we are more than 1,000 client here who's sending the traffic, so according to the load balance it send traffic to the particular server, and the connection, there is no connection limit we can deploy. So that all the drawback should be overcome during the era 1990s to 2000, early 2000. So as I said, connection limit, if the connection limit is connection based management, so if the connection limit is drastically increased, so in this 1990s era, we use instead of DNS, we use F5 for load balancing. What it actually do? So it's a client server again. It's a client server architecture. So what it actually do is while whatever the connection going through that particular F5, it will monitor this connection, and it's having more capability like monitoring the actual servers. If we have server 1, server 2, server 3, so it's monitor that server. Also, if any one of the server is down, it will be redirect the traffic. It will shut down this server. Means in the monitor, uh, that. But for example, S3 is no, it's down. Then for that particular time, it's continuously monitor that server. If it is down, it will remove from the load balancing method, and traffic is shifted to S1, S2 only. So that is one kind of thing we overcome during the era 1990s to early 2000. And there is a first product which is launched in 1997, 1997, the name given to that product is the Big IP. It's the first product, hero product of the F5 family. Also, it manages server traffic by directing it to a overload date server. Often use the layer 4 TCP UDP technology. This is the most important thing. It use the TCP uh, layer 4 of voice reference model. Layer 4 is nothing but transport layer. It's having the two protocol, TCP and UDP protocol. In the TCP protocol, as you aware of, as all of you are aware of, it's a connection oriented protocol. So basically, F5 is the mediator, is considered to be a mediator, and there is a separate communication between the client to the F5 and client to the F5 and F5 to the server. So it's is use the layer 4 terminology because of this manipulation of data, encryption, decryption of data. So many certification. So that all the capability we can introduce into the network by using the F5. So this is very intelligent, it's intelligent as well. So after that, second generation and the rise of F5 big IP mid 2000 to 2010. So next is 2000 to 2010. So during this decade, there is an application delivery net controller ADC. Load balancing involved beyond a simple traffic distribution into the ADC. So ADC, what is ADC? I have covered in the separate video. You just go through the what is ADC. So basically, in short, if I can say, in short, it's having the capability to provide service from capability of L4 to L7. So it's manipulate the traffic shifting as well. Also the layer 7 HTTP traffic inspection and SSL interception. That all this thing can be handled by the F5 in that particular. Also, during the same era, F5 introduced the TMOS architecture. TMOS is nothing but a traffic management operating system. So it's a first time F5 introduced the TMOS architecture, which is basically depend on the traffic manipulation, including HTTP header modification, SSL offloading, improved application performance. That all the capability introduced by the TMOS family. So, what is deep traffic manipulation that we can see? The next video is fine. So, include HTTP header modification, SSL offloading. What is SSL offloading? So, encryption and decryption of data while sending from the source to destination. DDoS attack should be prevented because of this. So, TMOS is having capability of providing that types of application performance. So, that is so we will cover the next video what is TMOS is. And its other functionality is era introduced session persistence. So persistent session persistent or sticky persistent. So that is persistent. Particularly, what is persistent is if we are sending traffic while using any of the banking website. If you want to, if you are doing any transaction, while doing the transaction, client initiate the connection to the F5 and it will go to the server. Consider is having server to server 3. So during that, if our traffic while doing the transaction, if we are traffic hitting to the server 1, so it will create a session and it create a persistent by using the persistent profile. Our traffic, the second packet come from the same client goes to this S1 only, not going to the S2. It will stick to the S1. So that is what the persistent is, and it's because of this, our communication can't lose, and that basically we are use these types of thing for the transaction purpose. So this is what the persistent is. Then after this is the second generation and the rise of F5 big IP in 2010. Then after we have the modern era, 2010 to present, right? So in that particular modern era, we use virtualization, cloud, microservice virtualization, that types of with the virtualization, we are deployed the by on the virtual platform, VMware or any other platform. Microservices and the cloud. So basically, it's the era of cloud. So we use a virtualized platform for F5, which can help and give the same capability that F5 is having. So instead of using the hardware, we are shifted our traffic to the software-defined module, virtual edition module. Now, in today's world, what F5 can provide is F5 provide hybrid solution, blended traditional big IP hardware virtualized application with a modern distributed cloud service. If, and handle complex traffic, multi-cloud environment. Basically, we it's our technology, it's a hybrid solution can provide capability to work on the virtualized platform and the cloud. TFI model in the evaluation. During the evaluation, deployment era of the load balancer shifted from simple load balancing connection to managing the entire application delivery chain. That is what we can see now. So previously we have only the load balancing capability. Now we have entire application delivery we are managed by the F5. What are the thing basically F5 leading charges from hardware-based application to the software-defined intelligence traffic management. So this is most important thing. So before it is only the hardware appliances. Now it's software-defined intelligence traffic management. And what are the device? What is the era it's having? Is like LTM is load balance and manage traffic within the data center. If you manage the traffic within the data center, same data center, then we have the LTM device. GTM is the global traffic manager, also called as a big IP DNS. Manage traffic across multiple data center. If we are having the two data center, one in the India, another is in the US. So if you want, if we are using the DNS, GTM, sorry, GATM for that. So in that case, if any client initiate the traffic, depend on the load balancing method, it is and primary and secondary data center, traffic is reaching to the India and US data center, depend on the load balancing and whatever the configuration that we are defined for this. ASM is act as a web application firewall to secure the traffic. So it's provide the security as well. So hacker can't access or any attacker cannot do any attack on the URL. So we have the F5 in between the path and will provide capability of firewall secure. We provide the security for the by introducing the firewall application firewall. So that is what the era is and all the module that is developed during that era. So to the next video, we have covered the rest of the topic. Thank you all for listening. And if you have any question, please let me know in the comment section. Thank you.